Some people call me Jag, some people know me as Jubar. That's me. And we're going to talk today about all things having to do with caching. So, congratulations. You managed to get your website out the door. Like, good for you guys. Like, awesome. Good for you. It's live. It's great. Neil Patrick Harris is like totally on board with your site. It's awesome. But then the bad stuff starts. So, sorry, not sorry. Of course, we lose money on every sale, but we make nothing volume. The problem with scaling out horizontally to deal with growing demand is it gets expensive. Heroku is really pricey. Performance L dynos, the big ones, $500 a month. That's great. Premium for PostgreSQL servers, $1,200 a month each. So if you want a master or a slave, $2,400 a month. Amazon, while cheaper than Heroku, not a lot cheaper. M4 XLs are $180 a month each, and M3 XL multi-AZ RDS is $560 a month each. So in Django, one of the things that we emphasize all the time is, don't prematurely optimize your code. Don't solve problems you don't have yet when your current problem is, I don't have a website yet. But once you have a functioning website, you have problems, and now you have to solve them. And so what we need to do is start looking at ways to cache. The basic concept is that caching means being lazy, and more importantly, letting your servers be lazy. So computer science is the science of laziness. We take things that we've done before and we redo them. My goal in any day is that all the code that I write is something I've already written or something that I copied and pasted out of Stack Overflow. Those are good days. So if we don't let our servers be just as lazy as we are, we're going to be hypocrites. And don't be that guy. Nobody wants to be that guy. Don't be a hypocrite. So you got to cache. So very standard bait. I don't know who at Amazon came up with these icons, but they're really terrible. But I'm sure there's somebody somewhere in a basement in Ashburn that's really proud of these. So basic Amazon Cloud, that thing at the bottom actually is this is a virtual private cloud. Intuitive, right? You have your elastic load balancer going to a cluster of EC2 servers that's dumping some static content into S3 buckets, and it's talking to an RDS backend. Well, once we start throwing cache in this, we're really only adding two parts. We're sticking something like CloudFront in front of our elastic load balancer in front of our S3 bucket, and we're having our EC2 servers not just talk to RDS, but some kind of elastic cache. So that guy at the front is CloudFront or CDN of choice. And the guy in the back is some kind of elastic cache. Amazon supports Memcache and Rex. Those are the two we're also going to talk about today. So when we talk about upstream versus downstream, not everybody uses the same term. Actually, at one point in Django, somebody filed a ticket to have it all changed, and they did. So Django's used both orientations. But for the purpose of this, Memcache and Redis are examples of upstream cache. And a CDN or Varnish or Squid are examples of downstream cache. Basic concept is that upstream is away from the client, and downstream is closer to the client. So upstream cache saves the results of expensive calculations that are frequently made. If we've done something once, and if it doesn't change to do it again, we don't do it again. This is different than denormalization. So denormalization is where you have a fully normalized data model, so you only have one copy of each piece of data, and it's a perfectly computer sciencey relational map. But then you make copies or derivatives of it for things that you need already pre-prepared. We're not talking about that. Caching is, by definition, ephemeral. It's temporary. You should be able to throw it away, and nothing bad should happen other than things slowing down a little. Two ways that we really approach this. So you cache a value for some kind of a fixed lifetime, which you're willing to accept stale values. It might not be current, but for the next 30 seconds, next 60 seconds, next hour, close enough. The other approach is to invalidate cache values when you're saving the updated values of the inputs that went into them. So if you're caching an aggregate of the count of something and you add a new one, you invalidate that cache value so the next time you go through, you update the cache value and everything stays current. But there are good ideas and bad ideas. So some things that are usually naturally good candidates for upstream caching, properties. Properties on classes are methods that act like attributes, in that you can get, set, delete, and execute some kind of a method, but you don't need to use the parens at the end when you reference it. A lot of the times properties are calculated, and that's why they're not just attributes. And we don't like writing parentheses sometimes, so we don't do that. Properties are excellent opportunities for caching usually. Anything that we compile, so Jinja templates start out as something in text. We compile it into a programmatic structure, and we can pickle that, serialize it, and cache it, in which case we don't have to go through the computational steps of figuring it out again. Anything which is generated. So if you're running an image site and you have a large copy of an image, you need to make a small copy of the image. As long as the large copy of the image doesn't change, the small one's not going to change either. So calculate it once and cache it for the future. And aggregated things. So generally speaking, aggregates are slow to figure out. You have to do iteration, you have to do counting, you have to do max, min, various other operations that you can simply cache the result of and reuse that calculation in the future. So those are some good things. Some bad things would be rarely accessed things. So the point of caching is that we want to not have to do again something which we've already done. But if we're not going to do it again, there's no point in caching the result. On top of that, since caches eject things which, when they're full, caching things which you don't ever use the cached copy of is really wasteful of not only your space, but also your processing time. Highly volatile things. So things that are changing so rapidly that you will invalidate the cached copy of something before somebody else gets a chance to even access it is also a pretty bad candidate. Caching things that you then have to throw away because they changed already, really not a good use of this approach. Anything you need to be there the next time you ask. Cache is a volatile storage. It's an ephemeral storage. You should be able to throw it away and your code will function just fine. If you need it to be there, it needs to be in the database. It needs to be in something durable. It needs to be in something that you trust to be permanent. Or things that you should be denormalizing. Particularly if what it is that you are deriving, the derived value, is something the database actually has to work with. It's a join constraint, or it's a where constraint on a SQL query. That value has to be figured out in the database, so that's a good candidate for denormalization versus caching. Then there's just some tricky things that might be good, might be bad, depending on your situation, but you really should consider them. One of them is ORM objects. So if you take a Django query set, sure, you can cache the results of that Django query set. And you can retrieve the copy of that cache. But let's say you cached a model object, and then you pulled it back out, and you changed one attribute, and you hit save. Well, another thread might have modified that object in the database between the time when you cached it and when you retrieved it. In which case, you just overwrote somebody else's changes. So if you're dealing with ORM objects, so database, object relational mapper objects in Python, and you put them in your cache, you need to treat those as read-only copies when you pull them back out of your cache. User-specific things. So we're going to talk about key space in a minute, but things that are specific to users that you don't want one user to cache and another user to be able to pull back out is obviously a bad idea. Security problems, privacy problems, all kinds of problems. So when you're caching things which are specific to the particular user, you have to pay attention. Also, not all things that are user specific will benefit from the caching because of the earlier things we were talking about, like rarely accessed or highly volatile attributes. If there's only one user that's going to be using this and this user only gets it once every hour, we're not going to get a lot out of caching that. Administrative only. So for example, I run a CMS and I make a draft copy of a page and I go and preview that draft copy. If I'm caching portions of the template render, or if I'm caching particular values based on the draft copy as opposed to the published copy, then that will get leaked to the public when anybody who's a public user goes and accesses that cache value. So if there are things that are staff only, be very careful not to throw them in your cache, include something to the public copy. Naming your cache keys is with a good, strong group, I think is a good idea. And a good way to build them is first hierarchical. So your cache key names should suggest some kind of a tree shape, that these things with the same prefix are related in some regard. The reason that this is beneficial is, one, in certain kinds of cache stores, it's easy for you to do blob searches on the key space in order to find related cache keys. Additionally, structuring it in that hierarchical way reduces the risk of collision, particularly on code bases where lots of developers are working in there. So having a cache key naming rubric ensures that two developers in two totally different parts of the code don't accidentally select the same cache key naming structure and start overriding each other's cache values. When we talked about user-specific data in cache keys, putting in the cache key itself all the values that this particular cache key pivots on is also critical. So if you're caching the last login time for a user, you need to put something that is user ID specific in your cache key, so you know that it's that user ID and not just the last user that you happen to save in the cache. And finally, a delimiter that won't appear those values. I've seen cache delimiters which were hyphens. That's not really a fantastic delimiter for your cache key separator, because the strings in between could themselves contain hyphens. There's actually a really funny article recently. Adobe Flex had to fix a bug because their SOAP client, a company that had an HR software and had an employee whose last name was Null, and couldn't submit anything through the SOAP client because null was treated as the value of null as opposed to the string null. I always use double colons. I don't really find double colons appearing anywhere else intentionally. And I also spaces it out really nicely. So for a user-specific key, I might do foo double colon bar double colon 123, where 123 is their user ID. The first upstream cache we're going to talk about is the file system. Yes, the file system. File system is a fantastic cache for large values. And when I say large, I mean things that are literally dozens of kilobytes. Thumbnails are generated images. File systems are great for storing images. If you talk to other third-party services and you're downloading large JSON documents for processing later and you need to save that between requests, file system is perfect for this. I mean, the basic rule of thumb is, if it's a file, the file system is a fantastic cache for it. So, I mean, paths themselves create a really natural key hierarchy. It's very easy to figure out and to explore the key space using all of your command line tools and all of the simple OS library path tools. It does have an actual built-in in-memory caching system. The Linux kernel endeavors to use every last bit of memory on the system. And even if the active programs aren't using it, Linux will remember pages off the disk that it had read previously, so that if any other future accesses to those pages of disk, it doesn't have to go back and spend it. Files come naturally with all kinds of things to tell us when they were made, when they were last accessed, when were they last updated, and even a fairly fuzzy locking system so that we can deal with some contention across the network attached storage. But I mean, basically, again, if you are trying to cache a file, if you're caching a thumbnail, file system is really the best place to keep that cache. It's not in database, it's not in memcache, it's not anywhere else. But then there's the added bonus that if we are dealing with file-like things, like I keep mentioning image thumbnails, you have the XSend file protocol. So if you're using the file system as your cache, we have basic system of the internet and Apache talking to some kind of WSGI thing that speaks to the file system. When you read, so if you have the file on the image on disk and you read it into your WSGI server and return it in some kind of an HTTP response to Apache, the basic steps that you go through are that Python opens the file, reads it, spools the entire thing into memory. Then Python sends the entire thing through the socket back to the WSGI container. And then your web server then sends that entire contents back to the end user. Apache, Nginx, all the major web servers have a secret protocol where you can avoid having to have Python read the file itself. So instead, when you want to serve that file, Python sends back to Apache an empty response, but with an additional header saying x-send file, path to the file I want you to serve. And instead, Apache treats it just like it would serving any other static file. And Apache is great at serving static files, whereas Python is not so great at serving static files. But Apache simply reads it and serves it right away. So using the file system as your cache in that sense, you don't have to read it back off the disk into Python the way you might with any other type of storage. It's x-send file in Apache. In Nginx, it's x-excel-redirect. Google that. It's more or less the same protocol. So after the file system, we've got everybody's favorite, memcached. Memcached has been around, and there's a lot of really good things about it. It's really easy. Like, it's very simple. It's just keys and values. Memcache doesn't even play around with durability. Memcache is entirely ephemeral. There's no way to configure it to where it's anything but entirely temporary. It's great at clustering. You can have a group of memcache servers. You can distribute the key space among them. You can make the key space redundant. It's fault tolerant. It's fantastic at handling these sorts of high availability configurations. Memcache always uses the LRU ejection method. So when the cache memory block is full and needs to cache something new, it's got to kick something else out. And so Memcache will use the least recently used block in its memory, eject that, and replace it with the new thing you're writing. So Memcache only uses LRU. But like I said, it's easy. It's been around forever. Like LiveJournal made Memcache like a long time ago. And it's really ridiculously fast. Most of the operations get set their big O1. But there's some downsides. It's actually really wasteful with memory, and we'll talk about slabs in a second, why it's really wasteful. But it actually is really, really inefficient in using your memory. It doesn't have any sort of key space exploration. You can't do glob-style searches for keys. You can't explore the key space. You can introspect the entire thing, but it's not really a legit operation. And it doesn't have any data structures. The only thing it really has are strings and integers. So you have a string, you can append to it, you can prepend to it, you can increment and decrement integers, but that's the extent of the types that you get in Memcache. Anything else your code has to interpret to serialize, deserialize, totally up to you. So slabs, and if there's one thing you need to know about operating a Memcache server, this is probably it. And this is one of the biggest reasons why, for example, I keep saying image thumbnails, why it's a bad idea to throw these in the Memcache. So the way that Memcache organizes its memory is it breaks it up into pages. By default, these are 1 meg. Later versions of Memcache, that's a fully configurable value. But within each page, it breaks it down into slabs. The slabs are, there's a list of different slab sizes that's determined upon starting the server. So you got things 8 to 10, like it's like 1K, 4K, 8K, 16K, on and on. But there's a fixed enumeration of them. And any particular page can pick one slab size. And all of the blocks in that page have to be that slab size. So what this means is, let's say we have a 1 meg page with 100 kilobyte slabs. So here we go, one slab, 100 kilobytes. This is a 101 kilobyte string. So Memcache wants to stick it in there. Only problem is it doesn't fit in one slab. So Memcache has to use 2. So we just wasted 99 kilobytes of memory. Now that's obviously the worst case scenario, but if we're looking at like an average case based on just a random distribution, we're talking about wasting 50 kilobytes for every 100 kilobyte slab that we're using. So larger things like images themselves are particularly wasteful when you try to store them in Memcache. But this fixed slab size does allow Memcache that O of 1 because you have fixed chunks of memory. You know exactly where to go start looking based on address. Just take the slab size, multiply by an offset, O of 1. It doesn't matter how much you have in there, it's always going to be O of 1 to get the set. And that's why Memcache is so fast. So the larger the slab size, the more likely you'll be wasting memory in saving larger values, and the larger the values, the more you'll be wasting. So that's just a downside of Memcache that we accept in order to have the O of 1. But the larger the stuff that you're stuffing in Memcache, the more likely you are to be wasting up to 50% of the memory. So it'll be like 25% of the memory on your server. So the next guy we're going to talk about is near and dear to my heart, Redis. So let's talk about the good. Redis is more than just a key value store. It's a key object store. So it can relate keys to all of the basic data type primitives: strings, integers, lists, sets, Python called dictionaries, and even another type that's a scored set. So it's a set where every element has a floating point number associated with it. Redis is single threaded. So every single actual operation Redis does is purely atomic, because no other thread, no other client can do another operation until that one finishes. Only one thread in the entire thing. On top of that, it allows you to do transactional isolation. So it was a big deal when Memcache did the check to see if this is here and then set it as a single operation. In Redis, you can do any number of operations as a single transactional block. Redis has the option of persisting disk. Again, you should treat your cache like if the entire thing were to crumble apart, your code would keep working just fine, albeit slower. But at least if Redis is writing the disk, recovering from a failure means that you're not starting from a perfectly cold cache, you're just starting from a slightly stable cache. So that's an option that Redis offers. And Redis, especially the latest versions, has actually pretty good replication and a manager for high availability failover. So Redis has always had master-slave configuration, but if the master went away, you were on your own to figure out how to do that flipping, heartbeat, or whatever you want to do. But newer versions of Redis actually have a fairly robust failover and negotiation system, so that you can have a cluster, and they will elect a master. But not so good. There isn't that much, actually. One of the biggest ones, because of that single-threadedness, is that long operations block. So, if you have a list with 1 million elements in it, it might take 80 milliseconds to get the last one out. Doesn't sound like a lot, but during those 80 milliseconds, no other operation can take place on your cache because it's single-threaded. So,
Is the write block?
completely blocked, because there's only one thread, one operation at a time. So if you have, if you don't manage your data structures, understanding the complexity of the operations that work against it, you can get yourself into a situation where your cache is actually slowing you down because operations are waiting to talk to Redis. Redis is, with Memcache, unless you tell it to use more memory than you have on the box, Memcache can't out of memory. The kernel won't kill it for out of memory. Redis can out of memory, because by default, Redis does not do any key ejection. Redis treats itself like a database. You can configure LRU. You can configure it so that the same way that Memcache throws out the least recently used thing, Redis will do the same thing. It's just not configuration out of the box. The way that Redis calls malloc as the database in Redis, which like Memcache has to fit in memory. If you have, let's say I provision 1 million keys, and then I drop all but 2 of them, but they happen to be at the start and the end of the heap. Redis will not release any of that memory back to the system. It will fill it back up as new keys are created, but Redis will never, unless you take off the end of it, release memory back to the system. So Redis's memory footprint will continue to grow as your key size grows, as your key store grows. So if you don't set up LRU and you don't pay attention to your Redis memory, it's possible that the kernel will have to kill Redis because it's used up all the memory on the box. And Redis is absurdly fast, tens of thousands of transactions a second. It's not as fast as Memcache. Most of the operations in Redis are O of n, not O of 1. O of n is not bad. So accessing individual keys is O log 2 of n. Again, that's great. It's just not O of 1. So for many purposes, Redis is perfectly fast. It's still just not going to be quite as fast as Memcache. But we do have the advantage that this key object property gives us better models. So whereas with Memcache we're stuck throwing strings in there, which might be serialized copies of objects that we have to serialize and deserialize, but we apply our own semantics to those strings. Redis doesn't require you to do that. You can use list operations for sequences. If you want to keep the cache of the last 10 users who logged into your system. It's really easy. You have one key, that's a list. Push one on, pop one off, done. With Memcache, you have to make the list yourself, pickle it, push it in there, read it back off, unpickle it, but there's no way, you have to do those other operations in Python, create the new value, and then push it back. With Redis, you can do all of this inside of the cache itself. Set operations for collections, so anything that you might do with a set, to set arithmetic, a guaranteed unique list of things. You can do those collections inside Redis without that serialization, deserialization. Hash operations allow for two-dimensional records. You can have inside the key space effectively a Python dictionary, a one-dimensional Python dictionary, but you have a Python dictionary. So you can have a particular user's cache set and a bunch of keys for that one particular user. And so if you're invalidating everything that user did, you have one key to get rid of. And all of the user's information is in that one hash there. Hash operations, again, because it's a hash, accessing individual keys inside the hash is an O log 2 event operation. Scored sets are great for counting things and for time series. So it's a set that all of the elements in it have to be unique, but there's a number associated with it. I most often use this where the number was epoch seconds. And so I could push things in there with epoch seconds values, lop off anything which was older than this, grab anything which was in this time range here. It's fantastic for that. Also, if you're keeping track of scores in something, you've got a game, and all the players are elements of your set, and their score is literally their score in the game. You can keep track of those scores and increment and decrement them as you want. But on top of that, the key space is blobbable. So you can search the key space for anything which matches a particular pattern. So again, if we've done that hierarchy key space rubric, say separated by double colons, you can search for user double colon star. That will give you all of the keys that exist in your cache for that particular user. You can also then go delete all of them. So you can do very complicated explorations of your key space, including management of your cache. So great. All right, guys, upstream cache, we did it. So servers, keep it. Give yourself a hand. So your DB servers are no longer smoking. Your autoscaler is no longer hitting maxins. You're awesome. Put down. Get a page. So, your site got posted on Reddit. Oh, there it is. I got a page. What's up? Do you know what Reddit is? Why? Somebody said we made the front page. Now our site is down. Are you ducking serious? I don't know. Just fix it. I meant ducking. So let's talk about the other half of this, downstream caching. Share all the information on your points of presence. And everybody around the world will get a very fast, very close exit. That's why CDNs beat just having a squid server in your data center. And so downstream caches, we control them using, from the RFC, HTTP headers that tell the caching server, the CDN, what it is that we want it to do with this document and the rules for it. Almost every single caching server in CDN can tell you to go to hell and ignore those directives, but you can tell it what you want it to do. And so all this, like I said, is part of the HTTP RFC. So these headers that can be part of the request response cycle, they tell the CDNs whether or not a page can be cached, or tell an individual user's browser whether or not a page can be cached, how long you should consider that copy to be fresh for, and not have to go get a new copy. Also, if it isn't fresh, it can tell the end user or the caching server what the rules are about going and finding out if there is a fresh copy. And so let me just walk you through like how this works and how these headers interact. So we've got your end user, your CDN, and all of your stuff over there in Amazon. So the user makes a request and it goes to the CDN. Akamai then looks to see if it has a fresh copy of foo.html, and no, it doesn't. It has no idea what that is. So Akamai then repeats the exact same request back to your whole cluster, which we call the origin. Your whole cluster does the processing, it makes a foo.html, and it returns it back to Akamai. But it puts two very interesting headers in it. One of them says last modified, and it gives a timestamp of when this particular document was last modified. And then a cache control directive saying, you may hold on to this and consider it fresh for 1 hour, 3,600 seconds. Akamai says, okay, caches its own copy and passes the response, including these cache control headers, back to the user. Chrome then also looks at this and realizes that it can keep a copy of this for 1 hour. So let's say some completely different user then makes a request for the exact same resource. This time, Akamai looks at the request and to see if it has a cache copy, and sure enough, it does, from the last request. And so all it does is return the exact same response, including the last modified, including the cache control, but the origin was left completely alone. We didn't have to talk to any of our stuff at all. Akamai handled it all for us. So okay, an hour passes, so our max age is done. Akamai's copy is now stale. So yet another user requests the resource from the CDN. So at this point, Akamai says, well, I've got a copy, but it's expired. What do I do? Well, what Akamai does is it goes back to the origin, but it gives it a header saying, give me this if it's modified since that last timestamp, that last modified timestamp that we first got. And so our cluster then needs to make a decision. Did it change? I mean, if it's a file on disk, it's very easy to tell if it changed, but if it's an application server, we might have some logic to find out, did this page change since that timestamp? And if it didn't, all the origin has to do is give an empty response. It's 304 not modified. Whatever it is you have, Akamai, has not changed since that time. I don't need to make a new page.
The second snare, did it decrement the hour? Second example?
In the max age?
Yeah. Did it pass back? Does it pass back a decremented value or not?
Depends. So Akamai, depending on your caching server, some of them, I mean, they all keep track of the age. Some of them will give a max age of the original max age minus the age. Some of them will give it back just as an expires header, as in this is the timestamp this expires.
Okay.
There's
Is that handled consistently?
Unfortunately, with CDNs, nothing is done consistently. Each one of them has its own iniquities. Some of them ignore parts of RFC, some of them change must to may and whatnot. So the 304 goes back to Akamai. And so Akamai says, oh, okay, my copy is fresh. So the server said, even though I haven't gotten a new copy, the server told me it hasn't been modified, I can consider this fresh once more. So Akamai serves its cache copy back to the end user, again with the last modified timestamp from the original. So what this means is, in terms of efficiency, 200 is okay, but 304 is better. Guys, so the last modified, if modified since headers allow the CDN and the origin to simply say 304 not modified. Akamai can also say 304 not modified if it has its own copy. Alternatively, so we're talking timestamps with the if modified since and last modified. There's another way that the server can return a digest for that copy of the page called the tag, and the corresponding header of the request is if not match. And so if you present the e tag back and it matches the digest of the document that the server still has, it can again say 304 not modified, not based on date, but based on content. So that cache control header that gave Akamai its directives and gave Chrome its directives There's a lot of different properties. I'm going to talk about some of the more interesting, more common ones. And what's weird about these, and I don't know who wrote the RFC, but the intuitive meaning of some of these actually isn't what they mean. So I'm going to talk about what each one of them does. There's two of them in particular that don't mean what you think they mean. So the first is max age. That's the one that we saw. It is the number of seconds that the response can be considered fresh. It doesn't mean that it's discarded afterwards. The cache can still hold on to it, but it has to go back and validate that this is still a non-modified copy. No cache. You might think this means you can't cache this. You're wrong. No cache means that a caching server can cache it, but it immediately has to consider it stale. So it has to go back to the origin to validate before it can serve a cached copy. So no cache doesn't mean no cache, it means no fresh cache. If you actually want the caching server to never hang on to it, you have to use no store. No store means under no circumstances whatsoever should anybody keep a copy of this document around, shred it. Which is often why you'll see cache control, no cache, no store, because it's pounding the fist down on the desk about it. Private. Private's a fun one. Private means that this page was intended for a user. So a shared cache, like a CDN, shouldn't cache something which is marked as private. Chrome can. Chrome can cache that. You are the user of Chrome. Chrome can hang on to that. So if you have a document which is specific to a particular user, you don't want it in the shared cache, but a particular user can hang on to it so they don't have to go back and request it again. You can do cache control with private. Must revalidate. Doesn't mean what you think it means. Must revalidate doesn't mean you must revalidate it. It means you must revalidate it. So, like I said, CDNs and caching servers can override and ignore parts of the cache control directive. And some CDNs may want to hold on to a document longer than your cache control. So a SQUID server might be configured to hang on to this document for an hour when you gave a max age of 60 seconds. Must revalidate means, okay, if you're going to do that, after 60 seconds, I still want you to revalidate the document. So it's only after, so if the CDN is holding on to the document for longer than the cache control header stated, after, with must revalidate, the CDN may not serve that cache copy without validating it upstream after that point.
Compliant CDN is correct.
And then S-max age. So both CDNs and end users' browsers respond to max age. Sometimes you might want to tell the CDN and the end user different ages. So S-max age only talks to shared caches, to only the CDNs, SQUID, Varnish, things like that. So if you have an S-max age and a max age, the S-max age will speak to the CDN, the max age will speak to the client. If you have just an S-max age, the client will not cache it. And if you have just a max age, both CDN and client will cache. The other one that's really kind of interesting is vary. So you can instruct the CDN to cache different copies of the document based on the presence of certain headers. The most common one is accepting coding. So different users across the world present here are the different document encodings that I accept. If a user says, I accept big 5 only, and the document was returned in UTF-8, the cache shouldn't serve that document to that user. So the cache can then cache a different copy of the document, one in UTF-8, one in LAC1, one in big 5, whatever it is you want to cache it in, but it varies based on the encoding of the characters. The other one that you'll see really commonly is vary cookie, and you'll see this particularly in Django. Be wary of this one. It might make sense. I mean, like, you know, in theory, like that's a fantastic way to cache different copies of the document based on the user. Because every user will have a different session ID of their cookies, and that's great. The only problem is that we all use analytics, and we all use advertising stuff, and we use, you know, and those services all set cookies per request. So every request, the cookies change. And it's not vary on the value of this one cookie, it's vary on the value of the cookie header. So if Google Analytics, or if DoubleClick, or if Facebook, if any of them set a cookie from your domain that changes some value, you're basically, your CDN is now caching a separate copy for every request. Isn't terribly effective. So specific to Django, Django does these caching headers with two different middlewares. If you imagine shooting a bullet at an onion, on the way in is the request, process request handlers, and on the way out is the process response handlers. So the order is reversed on the way out. So the outermost middleware runs first on process request and last on process response. So Django sets up a fetch from cache middleware as the very first one, and a store in cache middleware is the very last one. So that one goes in, then the other comes out. So they have to do this as two separate middlewares. You can configure the default settings for the lifetime, things like that, in the settings.py. The cache middleware recognizes lots of different settings in there. And if you want to override any of those, Django has plenty of decorators to vary, to patch the headers, cache control this, all of that. It's all very well documented in Django. You can set defaults and then override on a per view basis. Two very big caveats. First one is if you touch request session, if you access it at all, at any point during the processing of a request, Django will set very good. Django figures that if whatever you did was session specific, it's not for everybody. And to make sure that you don't cache something specific for a user in a public cache, Django errs on the side of safety and gives very cookie so that each user would get their own copy, so that that question would be asked independently for each user. Again, with what I said about very cookie, I actually almost always override the default session middleware in Django that does this and have it do a no cache, no store if the session is accessed. But just be aware that by default, if you touch, just even look at the session, if the session gets deserialized in any way whatsoever, Django will set very cookie on the response.
Is there any functional difference between very cookie and no cache, no store?
Yes. So if you don't have any of those, if you don't have Google Analytics, don't have any advertising, don't have Chartbeat or any of those things, and the only cookie that you're setting is session ID, the shared cache will save a copy of that page per session. It's not optimal, but it'll do it. If you are using something like Google Analytics where your cookies change, a user's cookies change with every single request, very cookie basically is the same as no cache, no store, because you're caching values, but you're never going to request them. The second caveat is that Django does have 304 not modified support through e-tags. So you can enable use e-tags. What Django will do is it will take the response itself, run it through MD5, and that's your e-tag. So if a request later came back with a if none match that MD5, Django will return a 304 not modified. It's not a big gain because in order to figure out if the MD5 matches, it has to run the entire view and process the entire template and do everything except just deliver it back to the client. So it's not a big savings, but it's there. So if we want to get the best gains that we can out of using a CDN for our documents, we need to figure out ways to 304 efficiently. We want, as soon as a view starts, to figure out right then and there if we need to make a new page or not. So for detail pages, where it's a page about an object, if you track the modified timestamp of that object, a very simple query will tell you whether or not that object has changed since the last modified timestamp. And maybe in your application, if the object hasn't changed, the page itself won't have changed. So that one query, 304 not modified, done. No template, rendering, no other queries, no anything. You just return HTTP response, not modified, we're done. Don't forget to check not just the last month, not just the updated record of the object, but also the timestamp of your Git repo. Because if you've done a release, even if the object itself hasn't changed, you probably don't want to do a 304 not modified, but it's just something people forget. And when you do this, be sure to balance the max age settings with the volatility of your data. So you can set it to max age equals 0, and the CDN will come back and validate every single time. That might not be necessary. I mean, if you're running a blog and you publish one blog entry a day, you don't need it to come back and revalidate with every single request. You might do an hour, you might do half an hour. but balance what you set the max age to with the volatility of your data, so that even though returning at 304 is much faster than returning at 200, if we don't have to do anything at all, it's even better. But the real trick with this comes with user-specific content, because like I said, if you touch request.session, very good. So if you're serving content on a per user basis, so if you're having to cache a separate copy of the document for every user that comes to your site, the utility of your CDN goes down really sharply. Caches work best when we give them the maximum repetition of not having to do something again. So what it really requires is that you rethink the way that you build your web pages. And so you want to try to architect it in such a way that all of the common, user-independent, public, I don't care who you are stuff is the only stuff that's in your HTML response. That's the only thing in the response to the document. At that point, run some scripts client-side, do XHR requests to pull out the user-specific parts, because you'll be guaranteed that you have a cookie, you can bypass the CDN, make sure you're getting fresh data every time, but the majority of what it was that you return can be very easily cached by the CDN and returned to anybody who asks. Additionally, if we talk about detail pages that you can very quickly check that 304 just by if the object has changed. Well, it's rare that we only have one object on a page. There's related right rail content or something like that. If you do the same technique for using JavaScript and XHR to query that content, it's very easy to just check the last modified, to check the updated timestamp on your detail object. Even if the related content's changed, you can still do a 304 and still save some overhead. But as an example, here's a site I've been working on lately. This is a homepage for a portal for people going to med school. That's it. That's the only user-specific part of this page. But that I have to check to see if the user is logged in or not means that the CDN can't cache this page, or can't effectively cache this page. Because for every single user, I'm going to be varying the response. If I had the ability to go back and do it again, I would have not included this there, but had two XHRs which went out to go check the status of the shopping cart, to go check the sign-in status, and insert that information there. So that's just a simple example of how, just thinking about how you're building your web pages differently, and the parts that are common to everybody, but then the parts that are very user-specific, you can get a lot of your content into a CDN and have that incredible hit rate, and just spend your processing on the very user-specific parts and make sure that everybody talks to them. There's other weird stuff about using documents, serving documents through your CDN. Keep in mind, not every user will hit your site. If you're lucky, they'll barely ever hit your site. But that means that access logs pretty much tell you nothing about what your site's doing. You'll need to rely on some kind of client-side analytics to force the user's browser to ping something with every request, so you get any kind of information about the volume that you're serving. Your access logs are suddenly useless for that. Not all CDNs follow RFC, especially the older and bigger ones are particularly bad about it. The most compliant I've seen is one called Fastly, and Fastly is basically just Varnish. Varnish is very RFC compliant, but as an example of like weird non-RFC compliant stuff, I found out the hard way that Akamai just ignores cache control private. Who needs it? So we were in a CMS system for staff users who are logged in. We always return the cache control private because they might be previewing content which isn't otherwise published. But Akamai just ignored it. So we cached the unpublished stuff in Akamai, and so users saw unpublished stuff, despite the fact that our cache control header said otherwise. Purging things from CDN can take time, and it takes different amounts of time. Different CDNs are different. So, and again, we said the CDN has 100 points of presence around the world, and you're trying to purge one document from it. It can take some time to get around to all of those nodes to make sure that that injection happens. Some of them is lightning quick. Akamai, for example, takes about 7 minutes to something. Okay, so we got both of our caches. The penny-haired boss is very happy with us, and we're making it rain. So, try to stay humble. Good job, guys. Well done on scaling the website out with cache. So just to recap, you can use an upstream cache to reduce expensive calculations that are on the sub-page level. The derived value of this, the compiled value of this, the aggregated value of this. You should use the file system as a cache for things that really actually are files. And when you do that, use the X send file extension or the X Excel redirect extension in order to make sure you're getting it out to the client without having to spool the files in memory. For those upstream caches, you want to use memcache or Redis, depending on how complicated you want to make your application-specific logic. If you want the data structures, go with Redis. If you just want quick and simple, go with memcache. But make sure that you're using them for the smaller ephemeral storage. Keep in mind the various caveats, the good and not so goods about the different cache engines so that you can get the most performance out of the one that you end up choosing. Think about your key space. It's a part of your plan it so that, especially as your code base gets bigger, multiple developers, you don't start accidentally overriding each other's cache keys. And be careful about what you cache. And when we talked about ORM objects, user-specific things, be careful about what it is that you're caching so that you don't have cross-user leaking, so you don't save stale data. There's all kinds of little tricky complications that can happen. For downstream caches, the goal is to get your page in front of your user's face faster, and doing it without necessarily having to hit your origin. The CDN will deliver a cache copy of the page way faster than you can generate a new one. So when you are talking to your origin, inspect. So look at the headers that your site is returning for cache control headers, for vary headers, and make sure that they are what it is that you think they are. Also, quick caveat, if you're using the Django debug toolbar, you are always touching the session. So if you're using Django debug toolbar, you will never get a max age header in any of your responses. So in development, that's not a good place to test it unless you turn off debug. Try to optimize your code toward 304 responses when possible. So the faster that you can do less work and just decide, yep, I'm done, 304, the more responsive your website will be and the faster you will get pages in front of your users' eyeballs. When you're starting with a new site or when you're re-architecting the site, think about how to abstract out all of the public, common, doesn't change depending on who is asked parts into the page itself, and build all the user-specific stuff using JavaScript and XHR so that that public, I don't care who you are stuff can be quickly served out in CDN. And then know your CDN provider. Know their quirks, know their strengths, know their weaknesses, know how fast they can purge something, know what parts of RFC they ignore, know where their points of presence are, understand who your CDN is because they are not all alike. Shameless plug. So I run the Python group over at Celerity. It's a business acceleration consultancy in Tysons. We have cool clients, Fortune 500, big media companies, billion-dollar nonprofits. So our sites generally tend to be very high volume, so there's interesting problems. And it's actually a really fantastic place to work with smart people who are really good at their job and really enjoy where they work. So I'm hiring. Please come work for me. And otherwise, I'm happy to take questions, comments, rotten fruit, whatever it is you guys want.
Let's applaud before the rotten fruit. Rotten fruit.
Do CDNs work if you're over TLS?
Yes. You can use TLS with CDNs. If you want to do it on a document basis, they have two different ways they end up doing it. One is that you give them an SSL certificate and they install it. It's usually fairly expensive because they have to provision an entire IP address for you. Not everything supports the multi-IP address for SSL thing. But the cheaper way that they do it is they use subject alternate names. So you get like a 500 subject alternate names. And they use that one certificate and serve it out for all of those different sites. So that's less expensive, but it's still kind of expensive. Yes, but they do support it. It's just not cheap.
And then, are there Django libraries to handle 3 or 4 support? I'm thinking, give me the max timestamp for a
Because
join.
it's so application specific, whether or not we think the page is going to end up based on some queries, not that I know of. If somebody knows of the library, please.
Yeah,
speak.
I was gonna ask, do you have any best practices on where you might put that code in Django? Would you put it in your view code, or would you put it in like a, would you subclass your middleware?
I end up doing a mix-in for class-based views
Okay.
that just has an interface for, am I a 304? And so on per subclass, I throw that mix in, there will be logic for figuring out the 304 for that particular class. So it isolates and makes clear what it is that we're consuming. And oftentimes that results in data preparation. If you don't do a 304, try to tune the queries so that you're getting the information you need to make the 200 without getting too much information.
Yeah, that's an argument for putting it in view or related. Yep.
My CMS got a pretty good API, but whenever we republish an article on our side of things, we just tell them to purge its cache. Can you think of a reason I wouldn't just set my max age header to be like 30 years?
Well, besides the fact that your clients will also get that, you would want an S-max stage if you did that. But if something goes wrong, if that API isn't there, if there's some broken node somewhere, I mean, you can do it. I wouldn't, but and yeah, I mean, some of the like fastest APIs, like super fast, CloudWatch or CloudFront is not great. It's a few minutes. ACMA is like definitely like 7 minutes. So it varies.
Other than frantic text messages, like what is your procedure of deciding when you want to cache? How do you evaluate once you have cached it?
So for document caching through a CDN, it really depends on what phase the project is in. Are we using an off-the-shelf thing that would require a lot of digging into in order to avoid touching request session in the background part? So like for example, if I was doing a Django CMS site, I would have to do a lot of work in order to try to make sure that the background